Good morning, Start Stallions, and thank you for joining me on today's video. So go ahead and get out that journal or just get a piece of paper, whatever you've been using, and we are going to title today's notes, Multiplying, and Dividing. And then just a little thing over here with estimation. Because we are going to be estimating before we solve each of these problems. But they will be multiplication and division problems. So we can go ahead and divide our page kind of into first a T-chart. It's not going to be the best looking T-chart, but yeah, I kind of went from one line to the other, but it'll do. We're going to title one page, or one side, multiplication, and the other side, division. Okay. And then this T-chart, we're also going to split it into two sections, so that we end up with a total of 4 sections here. Alright. So, we're going to first do the multiplication side, and then we'll do the division side. We're going to start with just, not story problems or anything, just the numbers, just the equations. So, for example, we'll just string something kind of random together. 1,372 times 18. Okay. So, we have a 4-digit times a 2-digit. So that does affect how we do our standard algorithm, but we'll get there in a second. See, when we put that we were going to estimate, that estimation really needs to come before you actually solve the problem. Estimating afterwards can help. It can help you figure out if your problem is reasonable or not, or your solution is reasonable. But you really want to estimate beforehand. So let's look at these numbers and see what we can round them to, because that's the first step of estimating. When you estimate, we want to round to, well, you decide. Do you want to round to the nearest whole, the nearest tens, hundreds, thousands? It's your choice. The closer you round to, the more accurate. So if I round to only the ones place or the tens place, then my actual my estimate will be closer to my real answer. But also, if I only round that little of an amount, it won't really help me solve the problem, because I'm still going to end up with a pretty hard problem to do. So I'm going to round to the hundreds place. So I see 1372, and so I'm going to round that to 1,300. You see how I did that? I actually rounded down. You usually would round up with this kind of problem, but it's fine. I rounded down, and the reason I rounded down is because I saw this 18 over here, and I was already thinking, you know what 18 is really close to? 20. So by rounding one of the factors up and one of the factors down, I can kind of do this balancing thing to where my product might be closer to my actual answer. Because sometimes you end up with a really big overestimate, and then sometimes you end up with a really big underestimate. So we're trying to avoid that. So you might be thinking, how is that any easier? Like, how is 1,300 times 20 easier than this? Well, it totally is. You can do this problem in your head. You might not think you can, but it's because you're overthinking it. Remember, when you're multiplying something with a bunch of zeros, we can start by just looking at the 13 and looking at the 2. What is 13 times 2? Yeah, you know that, 26. So we write the 26. And then we go through and we count all of the zeros that we ignored. 1, 2, 3. And we just stick those zeros on the end. So there's our estimate, 26,000. All right, now let's solve the real problem. So to do this, we're going to set it up standard algorithm, just like this. The number, I'm not going to say the larger number on top. Instead, we say the number with more digits on top, okay? It just happens to be the larger number has more digits in this problem. So we start with the 8 times the 2, and that's 16. Carry the 1, drop the 6. 8 times 7 is 56, plus 1 is 57. Carry the 5, drop the 7. 8 times 3 is 24, plus the 5, that's 29. Carry the 2, drop the 9. 8 times 1 plus 2 is 10. So we have our first row done. And what this row, this 10,976 is, it's the ones place 8, just the single 8, times 1,372. So we've done just the ones place, just the 8 here, times this top number. Now when we move to the second row, there's a very important step that you do. You know it, you call it adding the placeholder, which, I mean, that's what it is. You're putting a placeholder there. But the reason you're putting a placeholder there is because when we move here and start doing this digit, that's not really a 1, right? That's not really a 1. Look at its place value. That's a 10. But mathematicians figured out that, hey, we can treat this like a 1 as long as we stick the 0 from 10 right there. And that's why we put a placeholder. Because that's not 1, that's 10. So we put 1 0 for 10. Alright, now we just simply multiply it out. 1 times 2, 2, 7, 3, and 1. Easy enough. You just get 13,720 because that's what 10 times 1,372 is, right? You just add a 0 onto the end. You already knew that. Okay, add it all up. 6, 9, 16. And we get 24,696. And that's pretty close to our estimate, right? I mean, it's a couple thousand apart, like 1,500 apart, but like it's pretty close. When we're working with numbers this large, our estimates aren't going to be a couple numbers apart or even a couple hundred numbers apart. They might be a couple thousand numbers apart, and that's okay because I can say that 26,000 is pretty close to 24,000. All right. Now let's move on to another multiplication problem. Zoom in a little bit. And this one, I want to prompt you, go ahead and pause the video after we get the problem set up and see if you can solve it yourself. And then you can always unpause the video and fast forward if you'd like, and then check the solution. And you know, if you got it wrong, then at that point I would rewind it and go step by step with me to figure out where you went wrong. But it could be a good learning opportunity for you to try to do it on your own first. Alright. So we're going to multiply with decimals this time. But the thing about multiplying with decimals is that it's not really different than multiplying with whole numbers. There's only the additional step of estimating, but we're already doing that anyway. So we'll do 28.5 or 28 and 5/10 times 6.74 or 6 and 74 hundredths. Okay? Estimating with decimals is actually really easy because I always just round it to the nearest whole. Especially when they're this small. They're not very big numbers. Like 28 is not very big, 6 is not very big. So let's estimate it. 28.5, I want it to be a really easy number to multiply with, like something I can do in my head. So you might be thinking, oh, well, round it to 29. I don't know about you, but I don't round with 29 in my head. But I could probably round with 30 in my head. So I'm going to go all the way to 30, because it's not really far. And then 6.74. I could probably just take that one as 7. I don't need to like go all the way to 10 or anything, because 7's a low number. So what's 30 times 7? Remember the trick from last time? You might be thinking, I don't know what 30 times 7 is. You really do, because you need to utilize this trick. It's not really a trick, but you get it. 3 times 7 is 21, and then add the 0. Okay, so we have our estimate. Now let's multiply. We put the number with the larger digits on, more digits on top, and in this case, they both have 3 digits. So really, we could put either one on top in the standard algorithm. It really does not matter in this one, because they have the same number of digits. I'll just stick the 28.5 on top anyway, because it was first. 6.74. Okay. So, because I have my estimate, I can just ignore the decimals. You're going to ignore the decimals and solve it as if this was 285 times 674. Seriously, just ignore the decimals. Alright, this is where I'm going to start solving. So if you want to solve it and check it on your own, pause now and go ahead and do that. If you want to go along with me, then let's keep going. 4 times 5 is 20. 4 times 8 is 32, plus 2 is 34. 4 times 2 is 8, plus 3 is 11. So we have the first row, 1,140. Now, obviously, it's not that big of a number, but that's what it is for now. Because again, we're ignoring the decimals. We're pretending like these are, 285, 674. So that was just a 4. But see, when we move here, we have to remember that we're pretending that this is this is not a 7, or this is not 7/10, that this is 7D. 7D. So that's the whole thing that mathematicians thought up adding the placeholder, right? Because that's not really a 7, it's a 7D. And let's get rid of those from earlier so they don't confuse us. And let's start with the 7. 7 times 5 is 35. 7 times 8 is 56, plus 3 would be 59. 7 times 2 is 14, plus 5 is 19. Have our second row, 19,950. Again, way too big, but we know we're going to put the decimal at the end. Let's get rid of those numbers that we carry. We don't want them coming back to haunt us and confuse us later on. Okay, last row. Because we still have a 6 here, so we have to keep going until all the bottom numbers have been taken care of. We did the 4, we did the 7, now we're on the 6. But see, this isn't really a 6, it's 600. And how many zeros does 600 have? Well, it has 2. And that's why we put 2 placeholders right there. Okay, we're on the third row, we're doing 2 placeholders. Now let's start with the 6. 6 times 5 is 30. Running out of room up here. 6 times 8 is 48, plus 3 would be 51. 6 times 2 is 12, plus 5 is 17. That's a giant number. That is 171,000. Again, though, we haven't added our decimals. So all these numbers seem huge, but it's because we're not adding decimals at this stage yet. We only put the decimal in at the very, very, very end using our estimate from earlier. Okay, add it all up. 0, 9, 2, 2, 2, 10, 12, 9. So yeah, that looks like 192,090. It's not. Look at our estimate, 210. Where could I stick a decimal that would get me somewhere around 210? Would it be here, 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 or here? Lots of options. But our closest one would be 192 and 900ths, or 90 thousandths, either or. You could say either or, they're the same number. So do you see how these numbers are kind of close? Again, they're not like a single number within each other. They're, about 28 or 18 apart, but it's still really close. that was still close enough for us to make our estimate. All right, moving on to division. All right, for our division problem, we will do, let's see, 7,200 divided by, sorry, I'm changing it up a little bit. I'm going to use that as my estimate. 7,000, we'll do a little more complicated number. 7,482, I use all the digits, right? Divided by 58. So I wanted to use a number like 72, but 7,200, but I'll tell you why in a second. So this is what we're dividing. This is our dividend and our divisor, and we're looking for our quotient. So when I'm estimating with dividing, I'm not even going to lie to you, it's harder. It's definitely harder because I need to look at taking this number and making it to where I can divide with this number. It's a lot more thought having to go into it. So I'm already thinking I could get that number 58. What do you think? 60? And then look at this, 7. So 60. We're thinking like we're looking at just the 6 and think of multiples of 6. Okay? Multiples of 6. And I usually look at just the first 2 here. That's 74. And I'm thinking, okay, what's a multiple near 74? So if I'm rounding to the hundreds place. And I know 6 can go into 72. I know that 72 is a multiple of 6. I know it's times 12. So that tells me that if I round this down to 7,200, and I know that's a big round down, and that's okay, but I know if I round that down to 7,200 divided by 60, that I can, what's 72 divided by 6? We said earlier it was 12. And then, this is kind of weird, but the zeros cancel each other out. It's just 120. So, that means, again, because it wouldn't be, just thinking estimate and reasonableness-wise, it wouldn't be 1,200, because that wouldn't make sense. Because that would mean 1,200 times 60 would equal this. Whoa, no it doesn't. That would be a much bigger number, right? Now we can actually go through and set up the standard algorithm for division and solve. So that's where we put this number on the inside of the box, this number on the outside, and then we start dividing using the standard algorithm. How this works is that we're going to ask ourselves, can I put 58 into 7? No. Can I put 58 into 74? Yeah. It won't go in perfectly, but I know it can at least go in one time. I know it won't go in twice, though. Minus 58. Let's see. That's a difference of, it's 2 to 60, and then 14 to 74. So it's a difference of 16. Now I pull down the next number. Okay, how many times does 58 go into 168? Ugh, I'm going to have to do some side math for this one. So I'm going to do 58 times 3. And I got 174, which was too much, just a little bit too much. So that means it's probably going to be 58 times 2, right? So we'll do the math for that. Get that number. It's 116. Subtract that. And I'm going to get 552. And then bring down the final number to, oh my. How many times does 58 go into 522? So that's going to be a bigger number for sure. But see, it's not going to be over 10. And I know it's not going to be over 10 because 58 times 10 would be what? 580. And that's just a little bit over that, isn't it? So why don't we try 58 times one number less than 10? 9. 9 times 8 is 72. 9 times 5 is 45. Plus 7 would be 52. So 522, perfect. Sometimes that doesn't happen, but that did go in perfectly. Oh, I forgot to take that 116 and write it up there. So the 2 I'm writing here from the 116 and then the 9 from the 522 goes right there. And those are pretty close. 129 is pretty close to 120. So that was a good estimate. Alright, last one. We are going to do a division with a decimal. Alright, let's make this quick. So, what we're going to do is we're going to take the number, let's see, what do we want to do? We'll take 1092.2 and we'll divide it by 43. Alright, so let's get our estimate in real quick. I think where I can do it. I'll do it at the bottom of the paper. Estimate. And let's see. So I'm already thinking, what can I round 43 to? And I'm thinking 40, right? And then, need to write it backwards. Okay, round that to 40, and then multiples of 4. Multiples of 4, that would be 4, 8, 12. Okay, so again, it looks like we'll use 12 again, because I can round 1092 to 1200. So, 1200 divided by 40 would equal 30, because 12 divided by 4 equals 3, and just using reasonableness estimate, it wouldn't be 300, because that wouldn't make sense. 300 times 40 would not equal 1,200, so it would be 30. And you could also just multiply it, right? 4 times 3 is 12, add the 2 zeros, it's that number. Alright, we're ready, we got our estimate, let's do this. 43, first things first, sorry. When when dividing with decimals, your first step is to take that decimal point from your dividend up into your quotient. First step. Just go ahead and do it. As long as you don't have a decimal over here anyway. Alright. Got it? Let's go. 43 cannot go into 1. 43 cannot go into 10. 43 can go into 109. Probably twice. 43 times 2 would be 86. 43 times 3. This is my little side math. I do this all the time. You should be doing it too. 129. Yeah, so 2 times. 2 minus the 86. Let's see, it's 4 to 90. And then it would be 19. So 4 plus 19 would be 23. And then let's bring down the 2. 43 can go into 232 how many times? Again, I'm going to need some side math here. Maybe try, I don't know, what do you think? 5? 15? 215. Oh yeah, that's super close. If I add another 43 to that, it'll go over that. So that's a good number. So I stick my 5 up here, subtract out my 215. And that would be 17, because I'm thinking it's add 15 to this, and I would get 30, and then plus the 2. But you can actually sit here and, carry if you need to. I'm just skipping it for time's sake. And then I bring down my next number, my 2. 43 can go in 172 how many times? Well, I have this number and this number, so in between there, let's try 4. Look at that. Perfect. 43 can go into 172 4 times. Minus 172, 0, and I'm all done. Now let's check to make sure that's reasonable. This is my answer. This is my estimate. Are they pretty close to each other? I mean, yeah, I would say so. 25 is pretty close to 30. That's not a bad estimate. All right. So, that is it for today. Thank you for joining me for this video. Hope you got some good practice in. The rest of the week we'll be multiplying and dividing with mostly whole numbers to tomorrow and Wednesday, you'll be dealing with some numbers and history about the Titanic. And then on Thursday, you'll be talking about some equation problems with variables. And then on Friday, I believe that we're going to practice a little bit with fractions, because that's usually one of the hardest things we do all year. All right, thank you for joining me, and have a lovely day. Bye.